Find the concavity for f of x equals x cubed minus 6x squared plus 9x plus 30, and just give the answer in interval notation. All right, so for concavity, we know that we need to find the second derivative of this function. Now we see that this is a third degree polynomial, right? So of course, in this case, we should be able to find the second derivative quite easily. So let's find the first derivative. Okay, just using the power rule at each step here. Right, we get 3x squared minus 12x plus 9. Okay, now remember, this is the first derivative. We use the first derivative to find intervals of increasing and decreasing, also to find if there's a local max or local min. All right, so the second derivative is what we need to determine concavity. Okay, so we'll take the second derivative of this guy. We get, what do we get? We get 6x minus 12. Okay, so now we want to find a critical number here for the second derivative. So let's set this equal to 0. And we'll solve. So 6x is equal to 12. Divide by 6, x is equal to 2. So this is our critical number, right? Okay, so what we want to do next is make the sign chart or the sign table. Okay, so there's only one critical number here for the second derivative, right? So here's 2. So now what we want to do is we want to plug in a number, right? Plug a number to the left, okay, like 0, and then plug a number to the right. It doesn't really matter, right? So 5. And we see that essentially we are splitting, right, this into two intervals, okay? And one of them is going to be concave up or concave down, right? So we have two different intervals. So this one's going to be concave up or concave down, and then this interval is going to be concave up or concave down, depending on the value that we plug in and the sign that we get, right? So let's try that. What is f double prime of 0? So f double prime of 0 gives us negative 12, which is negative. So what does that tell us? Okay. It tells us that this interval is concave down, okay? And f prime of 5. Now once again, we're not concerned with the actual number, right? We're just concerned if this is positive or negative or not. But when you plug in the 5, 30 minus 12 gives us a positive 18, which is positive. That's the key, right? This is positive. So once again, what does that tell us? It tells us that this function is going to be concave up, right? So concave down, wherever the second derivative is negative, right? So that's going to be from negative infinity to 2, and then it's going to be concave up wherever the second derivative is positive. So in this case, from 2 to infinity.